Streamlining measuring tasks is important, not only because it improves efficiency, but also because it minimizes error. Today's episode is about how to automate measuring tasks and how to gain insight from that. The man who knows all about this is Wietse. Hello Wietse, tell us who you are and what you do.
Hello Neil, and thank you very much for having me. The name is Wietse and I am a manufacturing software engineer. I am an owner of a Danish company called Calibras, and we automate manufacturing and quality control workflows.
That's an interesting subject, because what are today's main challenges in quality control?
That is a great question. So today's main challenges, especially in the light of the Industry 4.0, are interconnectivity and digitalization of the whole quality control workflows. So the fact that you have a factory, and modern factory tends to be more and more digitalized, more and more interconnected, in a way that we aim to streamline our processes and to extrapolate as much data as possible from our processes, to get as much as possible insights and to save as much as time and in the end, of course, resources as possible. In order to do that, you need to really get down and dirty with the interconnectivity of the whole factory, and the quality control part is extremely important, because this is essentially how we probe our factory. This is essentially how we probe our manufacturing process. The quality control is in the end the only thing that we know about our parts. This is the way that we reason with them, and as the time goes by, we want to have all of those insights in a digital world. That not only gives us the advantage of having everything available in the real time and computerized, so we can apply advanced algorithms like AI on it, but it also gives us the advantage of speed, as we no longer have to really spend so much time acquiring all of those measurements.
Yeah, and especially if I look to ourselves, that we of course have a factory producing parts, and it's all about making that parts more efficient, and doing a lot of that automation allows us to become proactive in steering quality instead of being reactive in steering quality. Can you take us through what kind of tools are available nowadays to automate these kind of processes?
Thank you very much. Being proactive is indeed one of the most fundamental reasons why we want to actually have data insights, so we can make these data-driven proactive decisions. So to automate quality control processes, there are multiple tools that are currently available on the market. There are different SPC, which stands for statistical process control softwares, that are sometimes desktop, sometimes cloud-based, that are available on the market itself. There are proprietary softwares that come attached with the measurement equipment, which you can hook up to and do some basic automation. There are different software suites from different, for example, industrial camera manufacturers that are enabling you to do the development and inside their workflow and connect multiple sensors, which would then work synchronously to collect the data from your manufacturing floor and then streamline that data either to an industrial PC, either to a PLC, and then ship it either to a cloud or on-premise software system that would then create analytical dashboards. But more often than not, we still have to do more often than not, to really properly solve the problem that is on the factory floor. We need to develop custom solution using all or some of these tools and interfaces that are provided by the original equipment manufacturers. So there is engineering work behind it.
Yeah. What are some of your go-to or favorite tools in automating these processes?
Well, I am I am of a philosophy that the best tool is the one that is first and foremost close to you, the closest to you, and the second that it's integrating the best into the end-to-end workflow of the client or the customer that I am dealing with. It doesn't make a lot of sense if you are going to require from your client to suddenly adopt different SPC's software just to be able for you to extrapolate and use some kind of a some kind of an abstractive function that is available in this solution. So to put it shortly, I do prefer to interact with the equipment on a fundamental level, and I do prefer to adapt to the already existing ecosystem that is available in the factory. When it comes to, for example, computer vision, I would say that I have a big preference toward working with independent SDKs that are available, that are enabling me to have the image from the camera directly into my C++ or into my Python code. Same goes, of course, with the 3D scanners themselves, because in the end, with this, I can quickly iterate, I can quickly create a prototype and align with the customer of what is exactly that they want. That is not always possible. Sometimes the solutions that I need to develop are already have to be just one step above of what customer already has, and that there is not so much wiggle room. Then you need to learn.
Yeah. So, but reading between the lines, it's really important that when you buy a solution or buy a software suite, that it is either open source or has extensive SDK or API capabilities.
Correct, absolutely correct. So if you want to have, if you have a software that is doing its job, that is interacting, for example, with your 3D scanner, with your measurement equipment, and it's doing this job on a daily basis pretty good. It also, if you have a choice, choose a software that is modular, and choose a software that definitely has an API layer attached on top of it. This creates so many options. This creates so much flexibility to then move this data around your ecosystem, to send this data to other interfaces, use it in a different way, which opens up so many doors to automation. Integrated systems are only good if you don't go out of their comfort zone, and sometimes and more manufacturers, original equipment manufacturers, are actually realizing that it is actually quite beneficial for them to open source their APIs and to open source the scripting layer towards their software. They keep their core values, their core business, but they open up their tool and their software to be used in so many different ways, which then expands their reach and which then expands the way that their product actually can be used.
Yeah, and I think a nice example of that is also the project that we worked on together.
Absolutely. Thank you very much indeed. So the 3D scanning automation that we have developed together has been made using GOM-Inspect's API. So to give a brief introduction to our viewers, Neil in Parts on Demand is manufacturing a lot of components using 3D printers. Neil and his team has, correct me please if I'm wrong, 8 to 10 large EOS industrial machines, which are printing on a daily basis. And those machines are printing 1 to 2 batches per day on quite large build plates. And those printers are working basically around the clock. With every batch that gets out of the Parts on Demand production line, there is always one calibration component that is printed at the same build plate.
Yeah, exactly.
Yes, measuring this calibration component, with measurement of this calibration component, the parts on demand is then optimizing the printers on a daily basis and optimizing their parameters so they can always operate in a stable interval. And the conclusions on how to compensate and on how to actually perform this optimization are drawn from the measurement results of this calibration object. And what essentially our project did, we streamlined that whole procedure, which was manual at the
Yeah, because I can show I have some of the parts here. We use these kind of validation parts within our process to make sure that parts are produced within the right tolerances. And we already had a pretty advanced flow to measure these parts before, but it would take an operator between 15 and 20 minutes to generate a full report with all the machine parameters that needed to be adjusted. And I think we dropped that down to around 2.5, 3 minutes per part now, with automatic calculation of all the values, logging of those values, and putting all those values into a dashboard so they are visible and usable in the future.
Exactly, absolutely. So it as you say, it really adds up. 15 minutes per calibration part, couple of tens of batches per day. It comes to almost half a shift for a single operator, 2-3 hours at least per day. Not to mention that in this kind of a way, you don't have a trend line. You can't really do a long-term analysis if you don't digitalize and collect your data, and you don't visualize them over a series of time. You don't see actually how is your production actually performing.
Yeah, and maybe I can illustrate a bit. So the manual workflow that we had was we needed to scan these crosses, and the scanning is not like the really time-consuming part. So we use one of the GOM scanners to capture accurate measurements. But then in the data preparation and aligning the scan with the CAD model, that's what takes most time in a manual workflow. And we basically managed to create a script for that. So all those manual tasks are now automated, but also the data. So before we were just capturing the measurements and the software would just output the measurements, but those measurements are now put into an algorithm to actually calculate the machine parameters that are relevant for the specific machine and show if they are still in spec or that we need to proactively change those values in order to keep the process in specification.
Absolutely. So as you described, the procedure was the operator puts the part, he or she measures the parts, aligns them, extrapolates the measurements, takes those measurements into another software, either on an external table sheet, and computes the compensation factors and puts them into the machine. What we have done is essentially we have built on top of the existing GOM Inspect API to create a script that is capable of doing all of that automatically. So the workflow now looks like that an operator puts the component on a measurement table, aligns it in a designated position, types in couple of basic parameters like the material, the machine, and the data, presses the button, and then the script does everything by itself. The measurement is performed automatically. The alignment with the original CAD model is also performed automatically. The extrapolation of measurement results is performed automatically, and then the computation of the compensation factors from those measurement results is then also performed automatically. Those results are then dumped into a local database, which is then used by the local dashboard system to visualize the trend lines over the time, to showcase how different compensation factors behaving on different machines over the time and for different materials. over the different time spans.
Yeah.
That is creating some value. I believe you will agree. That is creating some real overview.
Yeah. So apart from like the time saving, so in other projects that you have done with like automating measurements, what kind of value did you see there that it brings a company or a factory?
It's a good question. Sometimes it was quite simple to really say to really see what the value was. Essentially, if you didn't even had the inspection line in place, or the inspection was purely manual, then just automating that and digitalizing that is a value for itself, because you free a single operator and a single worker. For example, I had a customer that I used to work for that had the inspection line of that had the inspection line of gas cylinders on for an oil and gas company, and the bottom of those gas cylinders was welded. The bottom of there was a welding procedure performed on the bottom of those gas cylinders, and sometimes those welds were cracked. And in order for us to automatically identify those cracks, they have placed 4 different cameras on taking the picture of the gas cylinder from the bottom from 4 different angles. And I have developed an algorithm for them, in this case AI-based algorithm, to segment and identify that crack. So there's a pretty obvious there's quite an obvious value there, because suddenly you no longer needed to really check every cylinder, manually check for cracks. If you have a good and robust data set, I think we had roughly 300-400 images of cracks and without cracks. You could create a decent algorithm that is able to then sound the alarm and say we have something suspicious running through our production line.
Yeah. And if I talk to a lot of other company owners or people that are involved with these kind of projects, it's always difficult to start somewhere. What's your best practice for starting your path in automation?
That's a great question, and it's unfortunately it has a very simple answer. It's you need to first digitalize before you can automate. And it's something that we can that we do on a daily basis at Calibras. That is something that we help our customers. You need to find a partner that is not afraid to take the ownership of your process and do what needs to be done in order to reach a certain degree of automation. If your partner, and this is me as a, I can give this as an advice, is only offering the automation solutions, but kind of offsets and offloads the data preparation and the data engineering to your sides, kind of assuming that you should already have the data in a nice format. It's not a good sign. It is those two are not separable. If you want to work with automation, you need to be capable to prepare your data as well for the automation. You first need to digitalize before you can automate. I would say start small. So the first step in each automation is monitoring. You need to be able to collect your data in a digital format and create monitoring dashboards to track trends and to see what is actually what is actually in your process that you have measurement from. Yeah. What is actually those things that you can't measure, you can't really automate. You need to see what are the available data that you can extrapolate from your factories. Do you need to buy some extra sensors? And then if you have to buy those extra sensors, install them and include them into this monitoring system. Are you working only with the time series? Are you working only with the Excel sheets? Perhaps this is also a pretty good use case for the factory automation. For one of my clients, I have automated their whole statistical process control, in which they have just dumped an Excel sheet that has like 80 1,000 different rows filled with measurements from their injection molding machine, and then the code afterwards splits them into different components and performs different statistical computations and visualizes those per those different batches. So it can be quite a simple start for. But you need to be first aware of what you can measure in your system and in what format you have your data available: images, time series, just the raw number, JSON files, CSV files. Visualize those, and then we can talk about the automation.
Cool. And if people want to get started, where can they find you and how do they reach out?
They can reach me out on our official email, so info@calibras.dk. We also have a website, and they are more than welcome to add me on LinkedIn, and we can then take it from there.
Well, thanks very much for this introduction into automation for quality control, and we'll keep improving.
Thank you very much, Neil.
Do you want to learn more about automation in quality control? Reach out to one of our engineers. And be sure to watch the other episodes of our SliceShows. See you there!